All right, let's look at an example of a confidence interval for means. So a faculty advocacy group is concerned about the amount of time teachers are spending each week doing schoolwork at home. A simple random sample of 56 teachers has a mean of 8 hours per week spent working at home after school with a standard deviation of 1.5 hours per week. Construct and interpret a 95% confidence interval for the mean number of hours per week all teachers spend working at home after school. So we need to identify the important pieces of information in here. So they took a sample of 56 teachers. Those 56 teachers spent a mean of 8 hours per week after their school hours. So, you work 40 hours a week, and then they spent an additional 8 hours on top of that working at home. The standard deviation was 1.5 hours per week. We want to do a 95% confidence interval. And then I'm going to just one more time highlight the word mean. That way I know that this is a mean, not a proportion. There's a lot of other things that tell me it's a mean. The word mean beforehand, standard deviation, no percentages besides the confidence interval. But also seeing the word mean yet again is a really good clue that this is a confidence interval for a mean. So the things that I need to write down on the side here are going to be X bar, S, N, and my confidence level. So my X bar is the 8 hours per week that they spent working at home after the school day was over. S is the standard deviation. N is the 56 teachers. And CL is a 95% confidence level. So the first thing we're going to do, these are not formal steps, but if you like following a set of steps, you can follow these first steps. The first thing that we're going to do is, if we haven't already been given them, we would find X bar and S. Sometimes we'll be given the values in the problem. Sometimes we'll be given the values from a data set, or we'll have to find them from a data set. So even though I've already been given these, I like to include this step every time just so that I don't forget that that's the first thing I would do if I had a data set. So X bar is 8, S is 1.5. I'm just going to rewrite it again real quick. Then the second thing that I'm going to do is find my alpha over 2. So alpha is 100 minus the confidence level. So 100 minus 95. Alpha is 5%. That's the percent of the normal, or actually, sorry, the t distribution curve that is unshaded. So alpha over 2 is 2.5%, and that is how much is unshaded in one of the tails. So that's the amount that's unshaded below the lower bound. Step 3, we're going to go find the t crit. So we're going to use a new function in Excel, t.inv, and we're going to plug in our 0.025, And then we also need to plug in our degrees of freedom. So I'm going to add that over here. Degrees of freedom is n minus 1. So in this case, my degrees of freedom would be 55, one less than the sample size. So let me go ahead and get my Excel open. Here we go. And I can zoom in. Equals t.inv, oops, 0.025, comma, 55. Enter. Negative 2.004. So I'm going to bring that back up here. Negative 2.004. I'm still going to cross out the negative. I don't want negatives. So I'm going to get rid of that negative. My next step is going to be to use the formula for the confidence interval. So that's x bar plus and minus the t-crit that we just found times s divided by the square root of n. And that's n, not df. So we're going back to the full sample size here. We only use the df in step 3, finding the t-crit. So here we have x bar is 8 plus and minus 2.004 times 1.5 divided by the square root of 56. That's kind of hard to see. So first I'm going to subtract. And when I subtract, that gives me the lower bound. So 8 minus 2.004, open parentheses, 1.5 divided by the square root of 56, close parentheses, 7.598. So that's roughly 7.6. And then I do it again. This time I add. And when I add, that gives me my upper bound. Eight plus 2.004 times 1.5 divided by the square root of 56. And that's 8.402, which if I round it to 2, that's 8.4. So the very last thing that I need to do is write out an interpretation. we are 95% confident that the mean number of hours that teachers spend working at home during the week is between 7.6 hours and 8.4 hours. And there we have it, a confidence interval for a mean.